For most of human history, the greatest threats to Earth came from within. Volcanoes, plagues, wars, climate shifts. But the universe has always carried its own quiet dangers. Far beyond the orbit of Neptune, beyond the familiar architecture of our solar system, objects wander through interstellar space with no allegiance to any star. Once in a great while, one of them drifts into our neighborhood. In 2017, astronomers detected the first confirmed visitor from another star system, Oumuamua, a strange, fast-moving body unlike anything seen before. Then came a second, and in 2025, scientists confirmed a third, an ancient, massive interstellar comet now known as 3I-Atlas. It is not coming for Earth, but if it were, the consequences would be unlike anything our planet has experienced since the age of dinosaurs. A messenger from another star. Interstellar objects are cosmic drifters, rocks, ice, and metal ejected from distant star systems during violent gravitational encounters. For decades, astronomers suspected they existed, but proof remained elusive. That changed with Oumuamua, whose speed alone revealed its alien origin. Unlike native asteroids, which follow predictable elliptical paths, Oumuamua tore through the solar system on a hyperbolic trajectory, moving far too fast to be gravitationally bound to the Sun. What made it even more puzzling was its shape. Instead of the irregular potato-like form common among asteroids, Oumuamua appeared extremely elongated, perhaps 10 times longer than it was wide, and tumbling chaotically through space. This unusual geometry combined with unexpected acceleration fueled intense speculation. Some even suggested it could be artificial. Further study dampened those claims. Most astronomers now believe Oumuamua was a comet composed largely of exotic ices, possibly hydrogen, which sublimated invisibly and provided thrust without producing a visible tail. Whatever it truly was, Oumuamua opened the door to an unsettling realization. Interstellar debris passes through our solar system more often than we once believed. Enter 3I-Atlas. Discovered in 2025, 3I-Atlas is only the third confirmed interstellar object ever detected, but it may be the most consequential. Unlike Oumuamua, Atlas behaves unmistakably like a comet. Observations show a bright coma and a growing tail, formed as frozen water and carbon dioxide vaporize under solar heating. Images captured by the Hubble Space Telescope reveal a cloud of dust and gas enveloping its nucleus, confirming that this object is actively shedding material as it approaches the inner solar system. What truly sets 3I-Atlas apart, however, is its origin. Trajectory analysis suggests it emerged from the Milky Way's thick disk, a population of ancient stars formed during a more violent era of galactic history. If correct, this means 3I-Atlas could be billions of years older than the Sun itself. While everything native to our solar system is roughly 4.5 billion years old, this comet may have formed as much as 7 billion years ago. In other words, it could be the oldest physical object humanity has ever observed up close. A composition from another era. Early spectroscopic data hint that 3I-Atlas is chemically unusual. In addition to water and carbon dioxide ice, astronomers have detected signatures of metals such as iron and nickel in its surrounding gas, an unexpected trait for a comet. This metal-rich composition suggests it formed under conditions very different from those that shaped our own planetary system. Studying such an object could provide a rare glimpse into how matter assembled around early stars long before Earth existed. But there is another reason scientists are paying close attention. It's speed. Speed is the real threat. Objects in the solar system typically move at around 20 kilometers per second relative to Earth. Interstellar objects are different. By definition, they arrive with excess velocity, unbound by the Sun's gravity. 3I-Atlas is traveling at a minimum of 61 kilometers per second, more than 3 times faster than the asteroid that ended the age of dinosaurs. This matters because impact energy scales with the square of velocity. Even if two objects are similar in size, the faster one delivers exponentially more destructive force. Could it hit Earth? Fortunately, no. At its closest approach in late 2025, 3I-Atlas will remain about 1.8 astronomical units from Earth, roughly 270 million kilometers away. It will pass inside the orbit of Mars but still miss that planet by tens of millions of kilometers. That said, astronomers are still refining its size. Current estimates place its diameter somewhere between 440 meters and 5.6 kilometers. The upper end of that range is where things become unsettling. So let's explore a hypothetical scenario, not a prediction, but a thought experiment grounded in physics. If the unthinkable happened. Imagine that 3I-Atlas entered the solar system on a slightly different trajectory. Imagine it went undetected until it was too late. No deflection missions, no last-minute interventions. What would happen if it struck Earth? To understand that, scientists look to a familiar benchmark, the asteroid that created the Chicxulub crater 66 million years ago. That asteroid was roughly 10 kilometers wide and struck Earth at about 20 kilometers per second. The result was catastrophic: a 100-kilometer-wide crater, global firestorms, mega-tsunamis, and a mass extinction that wiped out roughly 70% of all species. 3I-Atlas, even at half the size, would arrive moving 3 times faster. 4 times the destruction. Because of its extreme velocity, a 5.6 kilometer wide 3I-Atlas impact would release more than 4 times the energy of Chicxulub. The comet would punch through Earth's atmosphere in just over a second. At impact, temperatures would soar high enough to instantly vaporize rock, water, and metal. A superheated plasma core would incinerate everything near ground zero. Shockwaves would race across continents. Winds exceeding 1,000 kilometers per hour, stronger than any hurricane, would flatten forests and cities. Trillions of tons of molten debris would be blasted into the upper atmosphere. If the impact occurred in an ocean, global tsunamis hundreds of meters tall would surge inland, flooding coastlines thousands of kilometers away. Fire, then darkness. The immediate destruction would be apocalyptic, but the real extinction mechanism would come afterward. Dust, ash, water vapor, and pulverized rock would shroud the planet, blocking sunlight for years. Global temperatures would plummet. Photosynthesis would collapse. Plants would die, followed by the animals that depend on them. This impact winter, often called a nuclear winter, would be colder and longer lasting than anything humans have experienced. Acid rain would scour the land. The ozone layer would be severely damaged. Toxic metals would rain down from the sky. Even organisms that survived the initial blast would face starvation. A climate whiplash. Ironically, once the skies finally cleared, Earth could swing in the opposite direction. Because 3I-Atlas contains large amounts of carbon dioxide ice, its vaporization would inject massive quantities of greenhouse gases into the atmosphere. After decades of cold darkness, the planet could enter a prolonged period of extreme warming. First, a deep freeze, then a long, unstable recovery, assuming any complex life remained to witness it. No one escapes. There would be no safe continent, no untouched ecosystem. Civilization would collapse entirely. Even survival in underground shelters would be uncertain without long-term food systems. In theory, the only humans guaranteed to survive the initial impact might be those aboard the International Space Station, though returning to Earth afterward would be another challenge entirely. Why 3I-Atlas truly matters. Despite all this, 3I-Atlas is not a harbinger of doom. Its real importance lies in what it represents, a direct physical sample of the early Milky Way delivered to our cosmic doorstep. Studying it could help answer fundamental questions about how planetary systems form, how material moves between stars, and how common life-building ingredients are across the galaxy. Interstellar objects remind us that Earth does not exist in isolation. Our planet moves through a dynamic, crowded universe shaped by forces far older than humanity. And while extinction-level impacts are exceedingly rare, they are not impossible, which is precisely why understanding them matters. 3I-Atlas isn't a threat, but it is a reminder that our planet exists inside a much larger, older, and more unpredictable universe. Somewhere out there, other worlds are forming, breaking apart and sending pieces of themselves across the stars. If you want more videos that uncover these cosmic V and explain what they mean for us, like and subscribe.